Hello, everyone, and welcome to another Itential webinar. I am excited to have you join me today for a live demo on how to automate VXLAN fabric changes with Itential automation platform. My name is Jackson Flores. I am a senior solutions engineer here at Itential. Prior to working at Itential, I was a customer delivery architect at Cisco, and throughout my career, I have supported multiple customers in different verticals, such as financial institutions, healthcare, and service providers. Today, I'll be walking you through step-by-step how the Itential automation platform can help to automate VXLAN data center fabric changes and the processes that surround it so that you can keep pace with the rate of change required in today's networks. Feel free to ask questions along the way, and I'll answer them throughout the demo. So let's jump in. Data center fabrics provide network connectivity to hundreds and thousands of servers and applications, making changes to be required very frequently, making them also very tedious, complex, and prone to errors. The demand for changes can outpace the resources very quickly. Some organizations, in my experience, don't have dedicated teams, and some teams end up doing engineering work during the day and planning, and working change control at night, which can definitely put a strain on a lot of people. The configs we are demonstrating today, although being a basic configuration in VXLAN, can be quite complex with a lot of components. We're using a very basic configuration from a datasheet on Cisco devices, and it contains about 35 plus lines, which can make it very prone to error and also lack standardization. There are lots of network domain controllers out there that the vendors are building that are purpose-built for their own devices and or fabrics. These do a good job in managing configuration aspects, but they lack the integration capabilities that the Itential automation platform has to offer. Like we're going to demonstrate today, integrations with different tools such as sources of truth, IPAM, and notification systems can sometimes be challenging for other tools. And today we're going to demonstrate how easy it is with Itential. On this demo, we are going to demonstrate how a user can trigger an automation given some manual inputs by the user using our operations manager view and form builder. Then the automation will request VLANs and subnet allocation using the NetBox module for IPAM. Then we're going to leverage Itential's JSON schema transformation technology to create and merge all the data into objects that can be consumed and used to render configurations using our Jinja 2 templating engine. From there, we'll jump in and perform some configuration on at least 2 access switches or access leaves, in this case being a VXLAN fabric. Then we will automate some control plane validation. We'll do some show commands, verify routing tables, verify BGP tables, and that our advertisements are happening appropriately. And we're going to jump in and send notification, in this case to Microsoft Teams. As depicted on the right, we're going to leverage 2 forms of integrations and inputs. User input from an operator. We're going to integrate with NetBox for IPAM, and we're going to talk to Microsoft Teams for notification. We're going to leverage the automation gateway to talk to devices via SSH, and we have a little diagram of our fabric below. Let's jump into the actual demo. Please feel free, again, to ask questions along the way, and we'll try to answer them as they come in appropriately or at the end of the demo. Here we have the operator view on Itential automation platform. This is what the user will see when they're trying to create or make changes in their VXLAN fabric using a purpose-built automation designed by members of the team. In here, we can see listed the triggers that the users can leverage to start this automation. In this instance, we're going to use a manual trigger that is defined as user input. And you will see on the right, when I click here, we'll actually see a form that was designed for this automation specifically with some inputs that we will be leveraging later when we kick off the automation. In Operations Manager also, we have the ability to establish different types of triggers. As you can see here, when I click on the plus button on the triggers section, we can define different triggers as with triggers as API endpoints, where I can define my own custom routes and trigger this automation via API if I don't want the user to touch this UI directly, or I want to leverage an external OSS. We can trigger this by events manually, which is what we're going to demonstrate today, or on a schedule. In addition to that, the API triggers are very useful, especially when we're leveraging CI/CD pipelines, in which a pipeline can be defined to run an application or instantiate an application on a particular server to perform some automated unit testing, and a call into Itential can be made so that the appropriate network connectivity for that unit test is established. Now, before we kick off this automation, I want to go into the actual Automation Studio canvas and let's dive a little deeper into the steps of the automation before we trigger it and before we execute the whole change. This is the automation canvas for this particular automation. And as you can see, there are several steps that are included within this change. We start diving deeper into it. The first step that we're going to perform is to execute a JSON transformation or JSON schema transformation using Itential's engine to grab or take that information from the form that the user populated that I showed you before and that we will use to start the automation and put it into a format that the automation can leverage for its different requests or its different tasks. For example, there are certain things that have to be passed to NetBox, such as the site that we are going to request IPAM allocations from. For example, we're going to use Atlanta on this demo, and we have to give that information to NetBox, as well as the subnet sizing, and so on and so forth. Other inputs that are required throughout the automation are the device name and the interfaces where we wish to program or configure those access VLANs that we're going to be attaching this configuration to. The next two steps are some pre-built jobs that we have built to perform some basic functions on NetBox. One of them is to allocate a prefix or a subnet, and at the same time, allocate an IP address within that subnet. The reason for that IP address allocation is because this configuration will need a Anycast gateway IP address that will be configured on the access leaves for this particular change. Also, we perform an access VLAN allocation, and this will pull information from a NetBox pool or VLAN group that I will show in a second and pass it to the automation. If we go to NetBox, NetBox is actually a very useful tool that it's open source, and it's used for infrastructure resource management and functions like IPAM. So open tool, we use it for a lot of demos, very useful and very simple to maintain and work with. In this case, we have an IP address pool, which is 10.100/16, that I will use to request an allocation from. In this case, we already have 2 allocations. We will see an additional one added as we execute the automation. And then we also have a VLAN group that I called webinar within the Atlanta site that we will request a VLAN allocation from. As we come out of the steps of executing the allocations and the IPAM request from NetBox, we will run a second transformation. What this transformation is doing, and this is specifically where we can show the power of the platform, it will take that information from NetBox and transform the objects in such a way that they can be consumed across the rest of the automation, including our Jinja template that we will use to render the configuration that will go into the switches. This is definitely one of the pieces where we can add a lot of value, because adding requests to multiple disparate systems is something that can turn automations into a very complicated ordeal, especially for people using scripting. And there are other tools out there that just flat out don't provide the ability to do this and require you to provide inputs either manually or through text files or through YAMLs and so forth. Here in Itential Automation Platform, we provide the ability for the user to directly make API requests to disparate systems and then receive that data and normalize it across the automation so that they can leverage by subsequent tasks. After the data transformation from all the data received from NetBox, we will render a Jinja template that we have predefined for this change. Let's take a look at that. Within Itential, you have the ability to define Jinja templates, and they can be reused and will be exposed across all the automations by using the name of the template. As you can see here, templates can be developed on this GUI or this tool, or they can be brought in from your preferred editor, let's say VS Code. Here, we're not doing anything that most haven't seen before. This is a standard Jinja template using standard Jinja variables. And what we're doing is taking this snippet of configuration to define layer 2 VNIs, layer 3 VNIs, and all the rest of the constructs that are needed for server subnet to be instantiated into VXLAN, and putting variables around it so that we can automate this and create them on and on our platform. As you can see here on the left, I have used some sample variables that we use for testing and testing the template and making sure that it'll render appropriately so that when we go back and program it on the switches, it'll work. And we get a sample output on the bottom. Keep in mind, these are sample inputs. The input object in the automation itself will look very similar, but with different values. One of the things that I'm also able to accomplish with Itential is, as you hopefully caught on before, we're only requesting a subnet, an Anycast gateway IP, and an access VLAN from NetBox. And as you can tell, there is a pattern on the L3 VNI ID, L2 VNI ID, and overlay VRF VLAN. What we're doing here is we're actually using our JSON schema transformation that was executed before right here to derive these values in such a way that they are consistent and they follow a pattern. This allows us to keep up with standardization across the board, which is something very difficult to do when a human is executing these tasks. Another benefit of this particular configuration is that since it's very similar or the same across all devices, we're able to leverage the same template rendered configuration for all switches. After we render the configuration in this step, we have one more simple step, which essentially splits the rendered template object into an array of commands. Those are sent to our tasks that we have to configure the switches, along with the 2 devices that we have to push the configuration to, and some extra parameters, so we can execute all the changes in one task. Simple enough. From there, we will have a delay of about 20 seconds, I believe. Let me pop that in real quick to show. Yeah, so that is actually 20 seconds. And the reason for that delay is because we're actually using a real fabric, and we need to allow for the control plane to converge. So we give it about 20 seconds so that we can then, after, execute some commands to validate that things are coming up appropriately and we're getting the appropriate route advertisements. And I'm going to show that in a second as well. The way that we execute control plane validation is by using command templates. As shown before, on our Jinja template that we're able to leverage, these are defined using the command template app inside Automation Studio. And these can be leveraged for multiple automations. This allows the users and the operators to define their own pre-checks and post-checks for a given set of devices. Say, all the access leaves will follow my SIM pre-checks and post-checks, and then I am able to just reuse them constantly. Another thing that we're able to do here is define variables that I can pass within the automation to make sure that I am capturing the specific outputs that I need. In this case, I am passing the VRF name to this show IP int brief, and the same for the show IP route, and same here for some of the checks. Now, the checks on the left, here this one's using VNI subnet, which is also another parameter. What these are doing is actually, when they execute the command, they're expecting to get this back on the command output. And this will allow me to say if this particular automation failed or if it passed. And we will see that at the end. Another thing that we're able to do here is that we're able to execute this within the automation for multiple devices. So this allows me to verify very quickly all the devices that were touched within the automation, and I'm sure that I didn't miss any of them. At the end, or nearing the end, we will look at the mob template results, see the results of those, expand on the outputs, and then we will send a Microsoft Teams message. And we also have the option to execute a rollback. Let's go back to Operations Manager and let's trigger the automation. Before that, we can say here, using our manual trigger that was predefined before the demo, I will click on Run Trigger, and we will go along and select our parameters. For this instance, I am going to focus on the Atlanta site because this is where I have defined and we saw all the NetBox constructs that we're going to leverage, namely our IPAM pools and VLAN groups. They're tied to this particular site. In the tenants, we're going to select the application tenant. Subnet size, we're going to leave it as a /24 for now. That's most common that we use in our sites, in our demos. And for device names, we have a list of devices here. I want to keep device ATL, leave 01, and Ethernet 13, and ATL, leave 02, and Ethernet 13. I could add more devices as needed here. It is just as simple as this is a dynamic input table. So I can add as many devices and the same device again with multiple interfaces as needed. So if I needed to propagate this server subnet and access VLAN throughout the infrastructure, I could do that at will. We have a question on the chat. Oh, resolution, I will be adjusting it. Please let me know if you can't see it, and we'll keep adjusting it along as we go. Now let's kick off this automation. And this brings us to the Operations Manager view. As you can see, the currently operating task gets highlighted in blue, and it's actually going fairly quickly around here. But what I'll do is we'll start going through some of these steps and seeing what's happening while the switches are getting configured. That is a task that takes the longest time. So I think we're just going to go and look at some of the other stuff. As I was saying initially, the inputs are received from the user manually, like we saw on that form. But with the power of the platform, we're able to take this big object that comes out of that form and normalize it in the way that we can use it throughout the automation. For example, creating a device list array that will be used for the configuration task as well as the command template task. The subnet allocation from NetBox brings its own set of challenges, producing a very large output with some information that we don't necessarily need, specifically the initiator of the request, which is my email, as well as some IDs and things like that that we don't need, as well as the access VLAN allocation, which produces some other output with some unneeded information. So what we're doing with this automation is we're actually transforming this, executing a JSON schema transformation, taking all that information as inputs and producing a normalized output that we can reuse throughout the automation. Another thing, as I pointed out when we were talking about the template engine and the rendering of the template, is NetBox is only giving us a prefix allocation and a VLAN allocation, but using our JST, we're able to do some basic math and do some transformation on some of these values to derive the L3 VNI ID, the L2 VNI ID, overlay VLAN, and so forth, so that we're able to keep the configuration standardized across the board. So we only request one value and derive the rest, just as you can do with other constructs such as BGP communities and so forth as you go along, do changes. From there, we will render the device config. and we'll split it into an array of commands that I can show here. So this actually shows what is actually being sent to the device using our Itential CLI tool. This is just a set of commands, including the config line and a copy run start at the end with all the parameters, including advertisement into BGP and so forth. And as we can see here, while we were chatting and describing the automation, the configuration of the switches already went through, control plane convergence delay went through, and the control plane validation went through. Now, the control plane validation piece is specifically useful for me. I have been in many changes where part of many changes supporting different customers throughout my career, where the engineer pops up their Excel sheet or their notepad or the VS Code with a bunch of show commands that sometimes have a typo, that have not been tested or validated using any specific tool. Then they go copy and paste into the CLI. Hopefully it doesn't wrap and the device actually executes all the commands appropriately. And then they take their session log from Secure CRT or PuTTY or their preferred terminal client and have to spot check those CLIs. I've also been on the receiving end of it next day when somebody forgot to check a particular show command thoroughly enough and it caused some problem next day. Using our command template validation, we're actually able to establish some rules, as I showed before, that will validate that the automation actually went through and the CLI went actually successful. As you can see here, with our view mod template results task, we can see that the entire template as defined passed just fine. One thing I was able to do through the automation was, as mentioned before, I was able to define and create a task that ran this command template, and I was able to give it however many devices I needed to give it to. If I defined 3 or 4 devices on that user input form where we started the automation, it would have executed the CLI commands on all of them. So it makes it very dynamic. And like I was saying before, it makes sure that we didn't miss any commands on any devices. In this case, we were able to execute our 4 commands that I had predefined on our 2 leaves, ATL leaf 02 and ATL leaf 01. And we can tell that at least by our rules that we defined, they all passed. Another thing that you could do is these rules can actually be pretty involved and you could get very creative with them. We provide the ability to execute regex rules as well as contains, do not contain rules and so forth, just to make sure that, for example, if we're creating a BGP peer, we want to make sure it's not idle or it actually has the prefix number that is the prefix advertisement number that it's not 0 and so forth. You can get very creative with those. Another thing that we can do here is actually, okay, I see that it passed. That's good enough for now. But as we gain confidence with the automation, I want to make sure that I actually look at the output and I see that it's operating as intended. So one thing I can see here, I can see some of my VRF VLAN and my actual layer 2 Anycast gateway is being programmed appropriately here with my IP that got allocated. And we will see that in a second. If we jump back to NetBox, we can actually see that the IP address allocation just happened and it's 10.120/24 indeed. And that my IP address for the Anycast gateway is 10.121 and VXLAN webinar appears in the description. And when we go to our VLAN group pool for this site and the VLAN group webinar, we can see that VLAN allocation, VLAN ID number 2 was allocated for this. Going back into our command templates, we can see VLAN 2 was configured appropriately, and then the VLAN 1002, which was derived using our JSON schema transformation, was also configured appropriately. As we start expanding through all the other commands, we can see the layer 3 overlay. It's appropriately stop advertising routes for our subnets and for the Anycast gateway. We can also see here, we get an Anycast or a subnet advertisement for a layer 3 overlay. And we also have some type 2 routes in our BGP table. We can validate them here, looking the route distinguisher from each of my access leaves, 3111 and 4111 respectively. And we can see here where it comes from with our All3VNI 90,002, apologies, 90,002, which was also derived using our schema transformation by just providing the input of the access VLAN, which is number 2 in this instance. And this could go along for many, many, many server subnets. For the second switch, we can perform the same, keep expanding and make sure that I'm happy with the results of the outputs. And I'm pretty happy so far. So we're going to continue. And the last step would be to see a Microsoft Teams notification to showcase the powerful integration of the platform into different systems. And one of the things I am also able to do with this automation is take some of the values that were derived from our schema transformation and pass them to Microsoft Teams so that it can provide a formatted output in such a way that an operator or the person that actually requested that server subnet can get this message here stating that the Fabric server subnet provisioning was completed in the site Atlanta, server VLAN number 2, server subnet is 10120/24, and this is my Anycast gateway. So with this information provided to the server admin or the application admin that requested the change, they can go ahead and know now that their server subnet has been provisioned, and they can get away and start testing, and they already have all the information that they need. See if we have any questions so far in the chat. Oh, if you have any questions, feel free to ask them along the way. This is the end of the demo for today. Go to Itential.com for more information. The resources section will contain a recording of this webinar, as well as many others where we showcase the power of the platform, and we show how we integrate with different systems and provide more automation similar to this one. For now, I'm just going to roll back my change, clean up after myself. And thank you all for attending and giving me some time of your day. Have a good one.